In this proof, I'm told that AB is parallel to CD, that angle ABC is congruent to ADC, and that segment AB is congruent to segment AD. It's a little bit of a mark that I put on the diagram there accidentally, but it's AB congruent to AD. So that blotch on CD there you can ignore. I need to prove that ABCD is a rhombus, and to look at the different methods of proving a rhombus, of course I can prove four sides congruent, but keep in mind I have a couple of shortcuts here if I take a look at the textbook. One of my methods is to prove that a parallelogram has a pair of consecutive sides congruent. I can also prove that a diagonal of a parallelogram bisects two angles. I can also prove that the diagonals are perpendicular bisectors of each other. In this case, I notice that I'm already given consecutive sides congruent. So if I can prove that this is a parallelogram, I'm going to be able to get that rhombus idea very easily. And of course, we know that opposite sides of parallelograms are congruent, so if you wanted to prove all four sides congruent, you really could. There's nothing stopping you from doing that. So here's the thing that I'm going to do. Because of my parallel lines, I know that the alternate interior angles, this sideways Z, are going to be congruent. In this case, that is angle ABD congruent to angle CDB, and that's parallel lines implies congruent alternate interior angles. And what I need to do now is I need to prove that this other pair of lines is parallel so I can show my parallelogram. And I can now use the subtraction property. I have equal angles and I can subtract equal angles, and I can show that this angle on this side is congruent to this angle on the other side. So I can show that angle CBD is congruent to angle ADB, and that's because of the subtraction property. If you go back here, now I've shown that pair of alternate interior angles congruent. So I can say that side BC is parallel to side AD, congruent alternate interior angles implies parallel lines. As a result, I know that ABCD is a parallelogram, and of course the reason there being, if a quadrilateral has both pairs of opposite sides parallel, then it is a parallelogram. And now I've shown it's a parallelogram with consecutive sides congruent. Of course, if you wanted to show that BC was congruent to AD and that CD was congruent to AB, we also know opposite sides of parallelograms are congruent. But I'm just going to go ahead and say that ABCD is a rhombus. And the reason being, if a parallelogram has consecutive sides congruent, then it is a rhombus. There's the final proof.